A customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, measured in gallons per second, and t is measured in seconds. Part A. Using correct units, interpret the meaning of the integral from 60 to 135 in the context of the problem. Use the right Riemann sub with these intervals. Okay. So part A. First part of the problem is to interpret the meaning of this integral. So, first thing I would do, look at the table and look at what they're labeling it. T is seconds. Well, it tells you in the problem, but I would just look at that just in case. Seconds and gallons per second. Now notice, be careful that this says gallons per second. That means it's the rate. It doesn't say gallons at this time. It's the rate at this time. It's giving you the rate. So these are the rates, not the amount of gas. Make sure you know that, or else your whole thing is going to be wrong. So if you're finding the integral of all of this data and it's giving you gallons per second and seconds, the integral would be the change in the amount of all of this. So what you would write here is write the integral. So the integral from 60 to 130, or it is 135. F of t is equal to the number of gallons in the gas tank between t equals 60 and t equals 135 seconds. Okay, that's the first part of the problem. Second part is to use the right Riemann sums with these subintervals that they're giving you. So you would go up to the table they give you up here, and you would find these subintervals, and you find the difference between them in t. So this is 30, this is 30, this is 15. So those are your x's. Now for the y's, since it's a right Riemann sum, you would use the y values on the right. So this one, and that one. Because there's 3 rectangles, take the 3 on the right. If it asks you for left, you would do these ones and exclude that one. But it's asking for right, so you wouldn't do that. So you take the interval 30, then you take the first number, 0.15. You would add that to another 30, multiply that by 0.1, add that to 15, and then multiply that by 0.05. Put that through your calculator, you should get 8.25 gallons of gas. Alright, that's part A. Part B, must there exist a value of C for 60 is less than C is less than 120 such that f prime of C is equal to 0? Justify your answer. Okay, so this is an MVT problem. Mean value theorem. The 3 conditions for this are that the function is continuous, function is differentiable, and then basically the slope formula. So f of b minus f of a over b minus a is equal to f prime of c. So first things first, you got to establish that the function is continuous and differentiable before you can even use this equation, because the equation is basically useless if you don't establish that it's continuous and differentiable first. So you go back in the problem and you see it says f is a differentiable function. By that, it being differentiable, you already know it's continuous. That's an important thing you need to know. If it's differentiable, it's automatically continuous. So now you can try using the equation to complete MVT. So you find b and a, it gives you b and a right here. It's going to be b, that's going to be a. So put that in the bottom, 120 minus 60. And then you use the table to find these values, f of b minus f of a. So you go to the table, you look at 120 and 60. 0.1 and 0.1 are what corresponds to it. So you do 0.1 minus 0.1. Top is going to be 0, so the whole thing's going to equal 0. And then you look at f of c, which it gives you right here. F of prime of c, sorry, I meant f prime of c. F prime of c is 0. So that's how you know that there must exist a value for c. So you would write there must exist a value of c for 60 is less than c is less than 120 by MVT. Make sure you put MVT. It's going to be important. You're going to miss a point if you don't do that. So part C, the rate of flow of gasoline in gallons per second can also be modeled by G of t for 0, t, 150. Using this model, find the average rate of flow of gasoline over the time period or interval, and show your setup for calculation. So average rate of flow tells you you need AVT because it's asking for the average rate of flow of gasoline. This is going to be in gasolines per seconds. So you use this table to use you use this table and then you use AVT. So AVT is 1 over b minus a, integral from a to b, f of t dt. So in this situation here, it's 1 over 150, and a is 0, so you don't really have to put anything there. Here it's going to be 0 to 150, and then you put the function in. So you're going to have your graphing calculator for this portion of the test. So what I would do is first press y equals on your calculator, and then put this whole equation into y1. Because if you do it the normal integral way and try to put this whole thing into the integral, you're going to get really confused with parentheses, and you could like just make a parentheses problem and it can get your whole answer wrong, which you don't want. So the easier way is to first put it into your y equals, into y1. Then press math 9, which should pull up your integrals. And then make sure that whatever's inside, so it might look like this. So you put 150 on the top, 0 on the bottom, and then what's inside of these parentheses is y1. To get to y1, you click vars on your calculator. There's a button called vars. Then you go to yvars. Then you go to function. Then you go to y1. And then it should just pop in there. And then make sure it says d of x or whatever. And then you just press enter. You should get 0.096 gallons per second. So that's going to be your answer. And you show all your work, you're going to get all your points. So, part D. Using the model G defined in part C, find the value of G prime 140. And then you interpret the meaning of your answer in the context of the problem. So, for this one, make sure that y1 is still stored, or this whole equation is still stored into y1, this whole equation. So, now, instead of integrating, you're going to press math, and then 8. That should be your derivative. So most calculators, or some calculators, are going to look like this. And there's going to be the parentheses, then x equals something. So here, first is the x. It's going to be 140. It tells you that right here. So you make sure x equals to 140. And then again, you put y1. You do the same thing over here. And then you just put that through. You should get negative 0.0049. And you label it gallons per second squared. Now make sure it says gallons per second squared, because G prime is going to be gallons per second, the derivative of gallons per second, which is gallons per second. And then that's just going to be s squared. So make sure it says s squared and not just s. And then now to interpret it, it would just be the rate of flow of gas is decreasing by 0.0049 gallons per second squared. Now make sure it says rate of flow of gas is decreasing, because it's not saying that the flow of gas is decreasing by, it's the rate of the flow, because you just evaluated the rate of the rate already. So make sure it says rate of the flow of gas is decreasing by that number.